Welcome to my YouTube channel. I'll solve one problem from previous year question. So find the harmonic conjugate of this function e to the power x cos y plus e to the power y cos x plus xy. So harmonic conjugate always exists for a harmonic function. But this question can be asked that you are given uxy and then first checked is it harmonic. If this is a harmonic function, then find harmonic conjugate. So first we check the is it harmonic or not. So for that we have to check u xx plus uy equal to 0 or not. If 0, then it will be harmonic function, otherwise not harmonic. But the question is find the harmonic conjugate, means it is harmonic function, but we check in this problem. So let us check. So first ux equal to, we derivative with respect to x, so e to the power x derivative of e to the power x e to the power x, and cos y is constant, plus e to the power y is constant and cos y ka minus sin x, so this will be minus sin x, and xy derivative of xy with respect to x, this will be y, and uy equal to with respect to y, so this will be minus e to the power x sin y plus e to the power y derivative of e to the power y is e to the power y, cos x is cos x constant, and this will be x, and from this e to the power xx will be e to the power x to the power x, cos y is constant, and this will be e to the power y sin x the derivative cos x, and this will be 0, and from this u y equal to sin y derivative cos y, and this will be plus e to the power y cos x. So if we add this uxx plus uyy, we get this minus this, so this is 0 and this will be also 0. So therefore this u satisfy the Laplace equation. So from this we can conclude that u xy is a harmonic function. Okay. So now we find the harmonic conjugate of this function u. So for that we need ux and uy, and the other term I will remove. So let us assume that vxy be the harmonic conjugate, okay, of uxy. Then f equal to u plus iv is analytic, and this implies this f satisfies Laplace CR equations. So from this we get u x equal to vy and uy equal to minus vx. So we will use this to find vxy. Okay, so first we use this equation. So from this voy equal to ux, and ux is this, so ux is e to the power x cos y minus e to the power y sin x plus y. So we integrating with respect to y, we get vxy. So we integrating with respect to y, so with respect to y we get this is e to the power x cos y, integration of cos y is sin y minus e to the power y, integration of e to the power y is e to the power y, and sin x is constant, and y ka derivative integration is y square by 2. So we have to write here integrating both sides with respect to y. So therefore we get a function constant which is a function of x. So from this we get integrating with respect to y, so cos y ka integration sin y, e to the power y ka integration e to the power y, so e to the power x sin y minus e to the power y sin x is this. Okay, this is the vxy. Now we use this equation. So as this is the function of x, we will derivative this equation is 1. So derivative with respect to x, this is a function of x, so we have to derivative with respect to x. So then we find, so we get vx equal to e to the power x ka derivative e to the power x sin y is constant, e to the power y is constant, sin x the derivative cos x, and this will be 0 and this will be phi dash x. So now vx equal to, from this vx equal to minus uy. So we put this, you put this minus uy. So minus uy is e to the power x sin y minus e to the power y cos x minus x. So from this, Vx is, if we compare this, so if we compare this will cancel out with this will cancel out with this one, and phi dash x equal to minus x. So from this, by integrating both sides, we get phi dash equal to minus x square by 2 and one constant, that is k. So this is phi x. Okay, and we get Vx equal to this. So putting the value of this function phi x here, we get V of xy, that is. So ultimately we get Vxy equal to e to the power x sin y minus e to the power y sin x plus y square by 2, and this phi x is minus x square by 2 plus k. So this is the harmonic conjugate of this function uxy. So that's it. So in the next lecture, I will cover polar form of CR equations and polar form of Laplace equation. So this is very important question. You will get this type of question. So if you can solve this, you will able to solve this type of question. So this will be very beneficial. So if you like it, please subscribe my channel and share with your friends. It will be very beneficial for your upcoming exam. So thank you very much. Keep learning.